A model can fail before training even starts. Pandera schemas catch broken columns, types, and ranges before they turn into silent ML bugs. You'll learn the shape of a workflow that screens batches against a schema and halts training when columns fail. I'm Professor Pi, teaching AI foundations with simple Python. Data pipelines hand a lot of responsibility to raw tables. Missing or malformed columns sneak into training. Models then learn from garbage and surface subtle production errors. Validation is the gatekeeper that enforces a contract between data engineers and modelers. When you add checks early, you save debugging time and protect metrics that matter. At its core, Pandera lets you declare that a column looks a certain way. You can require integer bedrooms, restrict prices to a sensible range, and fail batches that violate those contracts. The tool fits naturally into a batch validation step before featurization. It is lighter than a full data catalog and more formal than ad hoc asserts. We will build a small pipeline that validates a baseline frame, promotes that contract into a typed model, surfaces errors with a report, auto-removes bad rows, and then recomputes a simple derived feature to prove the data is safe. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Let's start by validating the essential columns in a raw batch. This snippet ensures the core bedroom and price features meet basic type and range rules before any model ever sees them. Silence schema drift lets pipelines continue while counts drop below 1 or sticker prices spike. So we declare schema with pa.Column rules for bedrooms and listing price as a single source of truth. Calling schema validate raw df both enforces types and returns the frame, so downstream code can run on a checked data frame. The validated rows equals 3 output simply confirms every row past this guardrail in the first pass. Types and ranges are good, but errors can be subtle and many. We need a contract that reports every problem in a single pass. This example promotes the schema to a Pandera DataFrameModel, so you get a full list of violations in one go. I clone raw df into incoming df and deliberately corrupt demand by zeroing bedrooms and inflating high-end prices. The incoming batch class captures the same rules with type annotations, and pa.Field keeps checks next to the feature definitions. Calling incoming batch.validate incoming df lazy true collects every failure instead of stopping at the first one, so the exception carries a complete report. Printing batch issues equals 3 shows how many rule hits that drifted input produced before any training started. A full error report is helpful, but reading a stack trace is still slow. We want a fast pointer to the worst column. This code turns the Pandera error payload into a quick ranking of which field is causing the most trouble. When incoming batch.validate raises, the attached schema errors.failure cases frame gives a table you can work with immediately instead of wading through raw traces. Grouping those rows by column and counting them surfaces listing price as the hotspot, because 2 rows exceeded the max guardrail. The concise dominant failure equals listing price 2 readout points you straight to the field worth investigating first. Sometimes you want the pipeline to heal itself and keep flowing while you investigate the root cause. This snippet wraps remediation into a clean batch helper, so your pipeline can drop only the offending rows and continue. Invalid records quietly poison models, so the helper retries incoming batch validate lazily, and on failure, uses schema errors.failure cases index to remove exactly the bad indices. That surgical removal preserves the rest of the frame. The clean rows equals 1 output proves the automated scrub left a single trustworthy record from the corrupted input. With clean data, downstream calculations match expectations and are reproducible. This example feeds the cleaned batch back into the validated baseline, so derived features come from curated signals. I concatenate raw DF and clean DF, reapply the original schema, and compute a simple price per room ratio that mirrors a lightweight training target. Because every frame passed through Pandera twice, the derived metric reflects guarded data instead of drift-induced noise. The price per room 71250 print shows the sanitized dataset now produces a stable feature you can wire into an actual learner. Mapping this small flow to a real project is straightforward. Swap in your daily ingest, promote the DataFrameModel to a shared library, and route schema failures into your incident system. The pattern scales to larger batches and more features. It is a schema-first validation step for tabular features. Use it when you want deterministic checks before featurization and training. One caveat: strict schemas can reject legitimate shifts, so pair checks with a review lane or adjustable thresholds. A focused next improvement is to add an automated alert that opens a ticket when batch issues is at least 1, and the dominant failure names listing price. That ties detection to human review while keeping the pipeline safe. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.